Section 5.2, Day 1, Properties of Quadratic Functions in Standard Form. Please write down the essential question. How can I define, identify, and graph quadratic functions? In the last lesson, when we were talking about reflecting the parent function across the y-axis, we didn't do an actual example on that one, but I want to point out that what happens is when you reflect across the y-axis, that means your x changes. We did talk about that. Your x changes from a positive to a negative, but when we square that, that becomes back to your original function. That's all that's saying. Whereas when reflected across the x-axis, it flipped upside down. Axis of symmetry, what is that? That is a vertical line through the vertex of the function's graph. The quadratic function right here has the axis of symmetry at x equals h. So when the function is in vertex form, it's very easy to get the axis of symmetry. We just grab the value within the parentheses, but don't take the minus of it, take the opposite of what you see, and that is your axis of symmetry right there. It's a line that cuts the parabola in half. This shows that parabolas are symmetric curves. The axis of symmetry is the line through the vertex of a parabola that divides the parabola into two congruent halves. So example 1 says identify the axis of symmetry for the graph of, and there's the function. Well, we look inside the parentheses. That's where our h is. H is -5, because remember, it's always x minus whatever your h is. Well, that's where we got the plus, x plus 5 there. So remember, now our axis of symmetry is just x equals h, so it's x equals -5. On example 2, right here, we have, well, in this case, again, let's look inside here and look inside here to find our h value. Here, h is 2, so the axis of symmetry is that. Here, h is -1, so the axis of symmetry is x equals -1. So that's what it's asking for. Let's circle what we have. That's our axis of symmetry. That's cutting the parabola in half. Now, another useful form of writing quadratic functions, as we talked about, is standard form. Standard form looks like this right here. A cannot be equal to 0 because otherwise, if A is 0, it won't be a quadratic anymore. It will turn to a linear. And what all this information shows is you can go from vertex form to standard form by expanding this all out. That's what this is showing. Right. So here we go. Standard form now, we're going to talk about how we find the axis of symmetry when it's an ax squared plus bx plus c form. First of all, we know that the parabola opens upward if a is greater than 0. I call that a happy parabola. And if a is less than 0, then that's an upside down parabola. And I call that a sad. Oops. Parabola. So I'm trying to get, here we go. The axis of symmetry is the vertical line again, but this time the formula for axis of symmetry, you can't see that clear enough, it's x equals -b over 2a. We get the a, that's in front of the x squared, we get the b, that's in front of the x, and we calculate it. Again, the vertex is the point h, well, it's not hk, but it's different here, sorry. The vertex, the x value of the vertex is right here, -b over 2a. How we find the y value is by plugging the x value back into the function and find the y value. Plug in the input, get the output. And then the y-intercept here is always going to be your c value. Oh, and it talks about happy and sad parabolas. So let's look at example 3. Consider the function. So this function is in standard form. And we're going to answer a bunch of questions here. Determine whether the graph opens upward or downward. Well, the graph opens up, and that's because A is 2, B is -4, C is 5. It's because A is positive, so we can say up or upward. The axis of symmetry then is going to be x is equal to -b over 2a. We use that formula. So we have -b over 2 times a. That's a positive 4 over 4. That is 1. So your axis of symmetry is just going to be x equals 1. There's our axis of symmetry. There. The vertex then, well, the x value of the vertex is going to be 1. It's the axis of symmetry. The y value is going to be found by plugging in 1 everywhere there is an x in the original function. It's 2 minus 4 plus 5, 3. There we go. That's how we found, let's just draw an arrow. That's how we found the y value of the vertex. And the y-intercept is our c value. C is 5, 0, 5. If you forget that, you already know what it means to find a y-intercept. Remember, a y-intercept is a graph on the y-axis, and x is always equal to 0. So if you plugged in 0 for x, look at what would happen. You're going to get 5, 0, 5. So if you forget it's c, remember what you know about a y-intercept. Set x equal to 0 and solve for y. And let's graph the function. So our axis of symmetry is x equals 1. So let's do that right now. Let's see if I can do this. There we go. There's the axis of symmetry. And now the vertex we said was 1, 3. So over 1, up 1, 2, 3. And the y-intercept is 0, 5. 1, 2, 3, 4, 5. And now what we do to find a third point. We know the axis of symmetry cuts the graph in half. So the y-intercept was 1 to the left of the vertex. So then I can find another point 1 to the right because the vertex cuts the parabola in half. And then I can finish by connecting. It's kind of curvy. There we go. And there is our parabola. And the directions over here did exactly what I did. I did sketch the axis of symmetry. I plotted the vertex and the y-intercept, which again, the vertex is right there. The y-intercept, 1, 2, 3, 4, it's right there. And then I use the axis of symmetry to find another point because the axis of symmetry cuts the graph in half. Example 4, we're going to do in class. And example 5, we're going to do in class. Here's your video questions.